So today we're going to be talking about wind. So we already gone over pressure. Now we're going to look at wind. All right, so wind is the horizontal movement of air parallel to Earth's surface. So that just means it's flowing along the same path as the Earth. This air movement is due to air pressure gradients. It just means changes in air pressure. So we looked at air pressure. We know that there's different types of air pressure, but due to those differences, you now have wind. It's that air movement caused by those pressure differences. And so one of the huge causes, like you should star this, underline, highlight, uneven heating of Earth's surface. Huge thing. That's what causes wind. And it causes, so the uneven heating causes pressure differences. For example, land versus water. You saw that land heats up faster than water. Poles versus the equator. The equator gets hit head on, so it gets a lot of heat, whereas the poles get a really angled, long angle, so they don't get that like direct spotlight type heat. A dark forest versus snowfield. We talked about this before. If it's darker, it's going to heat faster. Remember that dark tank top? You're going to get really hot in that, opposed to a white tank top if you're out in the summer. So winds distribute heat energy from regions of low heat to regions of high heat. So that goes from lows to highs. Keep that in mind. All right, so now we're looking at this. So winds always travel from areas of high pressure to low pressure. Now, didn't you just say it goes from low temperatures to high temperatures? Well, let's see. From regions of low heat to high heat. So I know it's going to sound weird, but high pressures are low heat, means it's colder. Higher pressures, more compact. Think of it, the more compact, it's going to be colder. The more spread out, that's going to be hotter, which is going to be a low. And so cool air sinks, creating a high pressure at the surface. So you got all that cool combined air. And then you got warm air rises, creating low pressure at the surface of the Earth. And I don't know if I said it. So here's the thing. What I need you to write on here. If this is like a little mnemonic thing to help you remember. Highs are happy, lows are lousy. Just write that down. Highs are happy, lows are lousy. We're going to get into that later. Trust me, that's one thing you want to remember. Highs go to low. So highs go to low, cold goes to warm. Like cold air will push warm air out, typically. All right, so what the heck is this? Well, there are two types of wind that occurs between land and water. Have you ever been to a beach? Well, you notice that sometimes there's breezes coming off the water. This is called a sea breeze. Typically happens during the day. And so what happens? We know that the sun heats up the land faster than the water. So the warm air from the land heats up, it rises, and as it rises, that's a low pressure because it's all spaced out. It hits up top, and then it starts traveling along until it's out over the water. And then it gets colder because all that cold air from down below is starting to suck out all that heat. And then it starts to shrink back down and it starts to sink. And when it sinks, it turns into a high pressure. Now, what is this system called? All of it is a sea breeze. It's coming off the sea onto the land and vice versa. So sea breeze equals sun. Sea breeze, sun. Okay? And it's coming from the sea to the land. Ooh, now we've got nighttime. Well, what is this called? A land breeze. I wonder why it's called a land breeze. Well, because the ocean warms slower than the land cools off faster. The water doesn't. So it's warmer over the water than it is over the land. So all the warm air from the water starts to rise up. What does that cause? A low pressure. Then it travels inland and it cools down because remember, hot air goes to cold air. So it's following along to the cold air. And once it hits that cold air, it starts to cool itself down and it starts to compact and then it starts falling down again, creating a high pressure. This is called a land breeze. It comes from the land to the water. And this happens at night. So land is lunar. Lunar, think of moon. So land, lunar. Sea breeze, sun. Okay, so we've talked about all these winds. Now we have global winds. So global winds are created by an unequal distribution of solar energy. We talked about this. Unequal heating causes wind in terms of both intensity and duration. So this unequal heating causes different pressures, which results in winds. What would the global wind look like, or circulation pattern look like, if we were not going in a circle? Well, this is what you would see. You'd see these convection cells. Cooler air being denser, remember it sinks to the earth due to gravity. This causes warmer, less dense air to rise. And then you have that convection cell. That convection's coming in there again. So we saw convection when it came to lava. Now we're seeing convection again. In this, we've seen convection in water. So you've got convection in water, convection in the mantle. Now you have convection in the air, in the atmosphere, pushing around wind. All right, so we're going to watch these two real quick. I'm going to connect these to the notes. You are going to watch them also. And it's really, really cool. It shows the Coriolis effect. So wind direction, how does wind direction happen? Well, wind always goes from high pressure to lows, high to lows, and it causes something called a Coriolis effect. So Earth's rotation on its axis causes winds to be deflected to the right in the northern hemisphere and to the left in the southern hemisphere. I don't know if you saw like the clockwise, counterclockwise toilet thing, something similar, only with the wind. And so we're looking at this in the northern hemisphere. This plane is flying straight, but because the Earth is turning, it looks like the path is curved, which you will see in this. So I want you to watch both of these. I will attach them like I said. And now we're going to look a little bit further into the station models. So we saw this with the barometric pressure. On weather maps, the weather for each station is shown by symbols arranged around in a small circle. These symbols and the circle make up a station model, which gives the latest readings for the most important weather variables, which you can find right here in your reference table on page 13. Page 13 is a huge thing. So page 12, page 13, page 14, huge for this unit. You can see it gives present weather, tells you rain or whatnot, gives you dew point, gives you the temperature, gives you visibility, tells you the type of weather. And look at this, it tells you the wind speed and the direction. It tells you how much cloud cover there is, gives you how much precipitation there is, the trend if pressure is going up or down. Okay, so wind is a result of the Coriolis effect. You have that spinning going on, all right? So winds move in a clockwise outer spiral around a high, an anticyclone, which is like a tornado. So it's going to go out and around in a counterclockwise. And it moves in a counter, so it goes counterclockwise, and then because highs go to lows, it is now going to curve around and go clock. Okay, so this one goes clockwise, this one goes counterclockwise around a low pressure or a cyclone. Think of hurricanes. So tornadoes, clock, hurricanes, counterclock, lows, counterclock, highs. Think of like high C, clockwise, highs are clockwise, lows are counterclockwise. All right. So global winds, again, because of Coriolis effect. Coriolis effect causes convection currents to split into a total of 6 smaller cells, 3 in the north, 3 in the south. So you have 3 of them. One's a polar cell, near the poles. Then you got the Ferrel cell. That's where we are right now because it's between 30 and 60 degrees north. And then you got the Hadley cell between the equator and 30 degrees. And you have the Hadley on the opposite side going south, Ferrel going south, and polar going south. So they match up. All right, so looking at this, you have descending cool, dry air up here. And then on the other side, it goes in that circle right there. And I'm just going to click through this so you see these and you can write these down. So you've got rising moist air, which causes lots of rain. You're going to see that right here at the I want to say the 60 degrees, at 0, at 60 degrees. So 60 degrees north, 60 degrees south, and at the equator. Descending cold, dry. This is cold, dry up at the poles. It is cold, dry in between. Moist, so this is descending right here is descending cold, dry. So you got the warm, moist right here, the cold, dry right here. Warm, moist, cold, dry. Warm, moist, cold, dry. So this is what it looks like on a rotating Earth. All right, due to the, okay, so wind speed. The speed of the wind is determined by the difference in air pressure over differences, the distance. So this is gradient again. So wind speed, gradient. Pressure gradient. The closer the isobars means the faster the wind is going. See right here is really, really close together compared to right here. That means it's really blowing right here and really calm right there. The farther the isobars, the slower the wind. Remember, the closer they are with contour, the steeper it is. The farther apart, the lower it is. This is where, when you're looking at bars, this is what's going to happen. Closer, faster, farther, slower. Okay, so place an X where pressure gradient would be the greatest here. So you'd look where they're the closest. I put one right about here. Y where it is the lowest. I would say like right up here. Okay, so right here, what I could ask you to draw is isobars for the following lines. 1020, 1016, 1012, 1008, and 1004. Remember, 4 millibars, that's the difference. So I'm going to draw them and label them. And you'll notice they look like circles. And that's okay. And they don't have to flow all the way across like you see with temperature. These are actually circles because you have different, remember, highs and lows. All right, now I'm gonna add in the arrows of the way that the wind is going. And look at this. They're going around clockwise here. And now that we're gonna start going counterclockwise over here. Highs and lows. All right, so tomorrow we're going to look at air masses. If you have any questions, please get a hold of me. Actually, tomorrow's station models. So I'll talk to you then. Don't forget to Zoom with me. Don't forget to ask me questions. And I hope you guys have a great day.